Welcome to the third session of our complete ComfyUI course. In the previous video, I showed you how an AI model like Stable Diffusion generates an image, and we also built a text-to-image workflow from scratch. In this session, we will explore the image-to-image workflow in ComfyUI. I'll use Stable Diffusion models for this course because they are lighter than Flux, making them easier to run on mid-range systems. This way, even if your system isn't very powerful, you can still follow along and practice. Let's get started. In the previous session, you learned how a latent image is converted into a visible pixel image. To summarize, AI models do not generate pixel images directly because they cannot process pixel-based data. Instead, images are created in a compressed latent space and later converted into visible images using VAE decode, a separate node dedicated to decoding. In a text-to-image workflow, since we don't have an initial image, we use the empty latent image node to provide a blank latent space for the model to work on. However, in image-to-image, the process is slightly different. Instead of starting with a blank space, we use an existing image as the base for generation. To load an image into ComfyUI, I'll add the Load Image node to the workspace. Since we now use an actual image, we no longer need the empty latent image node, so I'll remove it. Why do we need to encode the image? The image we just loaded is pixel format, which the model cannot process directly. To make it usable for AI, we need to convert it into a latent image. To do this, I'll add the VAE encode node. This node is responsible for encoding the pixel image into latent space. Now, I'll connect the nodes. Output image from load image to pixels input. Latent output to latent image input in ksampler. VAE input in VAE encode to model output in load checkpoint. This setup ensures that our pixel-based image is properly encoded before it goes into the model for processing. Let's test it. I'll upload an image of a cat and set the prompt to a dog. Then, I'll click Q prompt to generate the output. Here's the result. As you can see, the model has generated a dog based on the original image. However, the result doesn't look very good and doesn't resemble the original image much. So, what went wrong? In ksampler, there is a setting called denoise. Why is denoise important? The denoise value controls how much of the original image is preserved. A high denoise value changes the image significantly, often creating an entirely new image. A low denoise value keeps more of the original structure, making it look closer to the input image. Since we want the output to resemble the original image more, I'll lower the denoise value and test it again. As you can see, the image looks a bit more similar, but the quality and details are still not precise and need further improvement. If you're not getting good results with your current model, you can try switching to a different one. For example, I'll switch to Realistic Vision Hyper instead of Juggernaut. You can download this model from Civet AI. I'll leave the download link in the caption. The recommended settings for this model are provided on its creators page on Civet AI, and it's best to use them for optimal results. I'll follow the recommended settings from its Civet AI page. The steps should be set between 4 and 6, and I'll set them to 4. The CFG value should be between 1.5 to 2, and I'll set it to 2. I'll set the sampler to DPM SDE++ and the scheduler to Keras, keeping the denoise value the same for now. Now, I'll click Q prompt again. The new result looks much better. Now, I'll adjust the CFG and denoise values for better results. The output now closely resembles the original image while still incorporating the changes we wanted. Always check the recommended settings for each model to get the best results. How can we change the image dimensions? To adjust the image size, I'll add the Upscale image node. Then, I'll connect the image output to the Upscale image node. Connect the upscale output to the pixels input in VAEN code. This ensures that the image is resized first before being converted into a latent image. What if I want to scale the image by a specific factor instead of entering exact dimensions? In that case, I can use the Upscale image by node, which lets me double or triple the image size dynamically. Depending on my needs, I can choose between these two upscalers. For now, I don't need them, so I'll remove them from the workspace. One more tip to make your workflow easier: how to quickly add an image to the workspace. Instead of manually adding the Load Image node, you can simply press Ctrl+C to copy an image from your system. Press Ctrl+V in the ComfyUI workspace to paste it. As you can see, the image is automatically loaded into the Load Image node, saving time. Similarly, suppose I want to use the final output as a new input for further processing. In that case, I can copy and paste it into the workspace and connect the necessary nodes. I hope this video helped you understand the image-to-image workflow in ComfyUI. In the next session, we'll learn how to use LoRa models in ComfyUI to enhance image generation further. Subscribe to Skillura and turn on notifications so you don't miss the next tutorial.